Hi guys, my name is Aman Pruthi. I'm working as a DevOps lead here at Velotio Technologies and I'm handling all things DevOps. Okay. So today we are going to be talking about observability part two. This is a part two where we'll be talking about logs, right? How do we collect logs and how do we inference and observe our system using logs, right? So let's get started. So guys, we are going to start today with how to work with logs and discuss about observability. Okay. So yeah, this like we discussed in our uh, last video too, which we talked about metrics at that point in time. Today we are going to talk about logs. So basically, if you read the definition, logs are the timestamp granular and comprehensive millisecond by millisecond records of application events which developers can use for troubleshooting purposes, right? So it forms one of the three pillars of observability. Right? We have talked about metrics, and today we are going to talk about logs and how do they help. So, like when we talked about metrics, right, we mentioned that we have to take care of the cardinality, right? That we can only put a certain number of things in metrics, right? This you don't have to be worried about this when we come to logs, right? Logs can be as verbose as we want them to. So, and they become all the more important when it's a distributed system and so many entities are interacting with each other. So how do you understand what is happening where, and the detail of that kind of thing is put in logs. So logs should be labeled and passed at source. Okay. So if you have a log in a text format or a CRI format, it should be passed and converted into a desirable format, and then it should be pushed to the destination as soon as possible. Okay. So, so here the meme says like log well, live well. So that is actually true because if your logs are not in a good format, it will be difficult for you to judge what kind of error you have faced and things like that, right? So how do you choose how to, do your logging? So first choose your collector wisely, right? So the agent that is going to be collecting all your logs from different machines or different containers or different nodes, and that will be putting it on the aggregator, right? So choose that wisely. And how do you choose it? You choose it based on what is its network throughput. Okay, what is the max rate at which it can send logs? What is the resource consumption? Okay, and what are the plugins that you need to use, to parse and format your data? So what is your input format and what is the output format you want? And if there is filter that is already available for you, so that will greatly ease your task, right? And choose your destination based on like what is the scale of your data, what is going to be the storage cost, and there's some advanced requirements like cross query clustering, cross cluster query, and setting up analytics and something like that. So we are going to discuss about two stacks, right? One is the EFK stack and one is the uh, PLG stack, right? So EFK stands for, so these are the two most widely used open source logging stacks. So EFK stands for Elasticsearch, Fluentd, and Kibana, where Fluentd is your collector. It collects your logs from all these different nodes and puts it into the Elasticsearch. Elasticsearch is a DB that stores your logs, and Kibana is your front end that can be used to query logs using Lucene or KQL, which is Kibana query language. Similarly, PLG stack is Promptail, Loki, and Grafana. So where Promptail collects your logs, puts it into Loki, and then Grafana can be used to query Loki, right? So this is a basic around both the logging systems, right? So now we do a quick comparison. So ELK or EFK stack, the visualization tool is Kibana here. Here it is Grafana. For EFK, it is like the Elasticsearch. You get high availability because it is clustered system. It is like multiple nodes. Whereas Loki is like a newer architecture. It's a microservices architecture where each part of the system is broken down into multiple pieces and you can scale any one of them, right from querier to ingester to gateway. So you can basically scale any one of these microservices depending on your requirement. So query performance is like faster for EFK, especially for older data because all the data is being indexed, right? But for Loki and Promptal, it is only indexing the log labels. So that is a little, so the query performance is a little small, but not very much too. So this is talks about index lifecycle policy. So if you have to search logs, right, you have to put it in a proper format, and that proper format, so it's a DB, right? So if you have to search in a DB, it needs to be indexed, right? So that you can easily find whatever you're looking for. So EFK or Elasticsearch basically indexes all your data, right? So it requires a lot of space to store those indexes, right? Whereas in Loki, you just index the labels, right? So that takes very less space, right? So uh, so 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 like we talked about, the query language is Lucene QL, or here it is LogQL, and pipeline is basically Fluentd. So Logstash or Elasticsearch, or you can put it directly to Elasticsearch as well. And here it is Promptail Loki, right? So that's about it. You can basically set up alerts using Alert Manager. There's nothing inbuilt for Kibana, right? So what are some of the advanced problems that we can solve using logging, or that we should consider while designing our logging architecture? One is, do you need buffering? So for example, you between your collector and putting it in the database, you can actually have a buffer. So for example, if your destination goes down, right? So if you can have a buffer like a Kinesis data stream or Kafka, so you will have data for that amount of time, even if your destination goes down for some time due to maintenance, or is not able to catch up with the volume of logs that are coming in, right? So it gets some time to scale and the data is not lost, right? So, and the second advanced problem that we can look at is cross-cluster querying. So, Loki currently does not support querying across basically multiple Lokis, right? So, the query microservice of it does not support querying multiple Loki, or there is no like proxy sitting in front of Loki. But that support is being provided by AWS OpenSearch, which is like Elasticsearch that is managed by AWS. So you can use Kibana to query different Elasticsearch behind the scenes, and the front end can remain same for the users, right? So what are the things that you should keep in mind when you're designing your logging architecture? First, determine the retention period of logs so that log archiving can be done periodically. So archiving, or you can talk about like index lifecycle policy, lifecycle management. So where you put in your logs from hot to warm to cold, depending on what is the frequency you're going to query that timeline. So you can basically put your logs into cold storage like after 15 days, because you're not going to require your logs after 15. That depends from enterprise to enterprise, what is the logging architecture. So third is set up correct replication factor to introduce redundancy, right? So imagine you've got clustered Elasticsearch and one of the nodes go down. So you should be still be able to query your logs and find out the errors. Your system should not come down. So you should set up the appropriate replication factor. And fourth is, have a correlation between logs, metrics, and traces. So if you have got the same label on which you search metrics, and you have the same label on which you can search your logs, that will be kind of great. So you can easily transition between, okay, you can see in metrics, you're getting a 5xx error. Okay, you go to the logs for the same evaluation time and get, okay, give me the logs for this component, right? So then you get that component and get the logs easily. So you check the metrics for that component, you check the logs for that component, and easily then you can go to traces if need be, right? So have a correlation ID that you can use to basically, so it can either, so for Loki, it is definitely labels, right? So you don't need to worry about that. So talking about Loki and setting it up like for newbies, how simple is it, right? So all that you need to do is add a Helm repo and run the upgrade command. So it does everything for you. It will install a Loki, and but if you want to go into advanced use cases, right, where you want to set up, decrease your query time, right? So then you can set up multiple queries and things like that. So that is something that you can look into. And this is the final dashboard like you can query on, right? So when I query based on, like, I'm saying that pod is equal to this, give me the logs for that pod. So it will give me the logs for that pod. So that's it, guys. So hope this will benefit you and in setting up your logging architecture. Thank you.